everyone, and welcome to the second ever episode of Cooking with Unity. The show's so nice we made it twice. Anyway, this episode we're going to be continuing on the last project that we were working on. I've put a download link in the social stream on the right, so if you need to download that, go ahead and do that, and hopefully you can work along with me. If you have a project from last week, just open it up, and we're going to start right where it's at. So, last week we had, let me open the level here. I'm going to open up the project and the level, and we have a little Space Invaders thing, at least the start of it. It fires when you hit Z, and you can destroy the little enemies. And we're going to work from here to make the enemies move, make it so that you don't have to manually place all the enemies, and once we're done with that, we'll see how much time we have and what else we can do. So, what we're going to do is start with a movement script for these enemies. So, we're going to create a new C# script. We're going to call this enemy AI to go along with our bullet AI theme, and we're going to open it up in MonoDevelop, and I'm going to try and reduce the amount of ums and ers this time along, but there's one right there. If I need it to think, I'm going to do it. So here we are in our update function, and what do we have on these guys right now? Do we have any? Okay, good. They don't have rigid bodies or anything. So we're going to move this using their transform. And let's make them move to the right until they hit the edge of the screen. I'm not sure exactly how we're going to check that right now, but we may have to give that to the enemies. Let's just see what we can do first. Let's just get them moving right first. So transform dot position. We're going to be changing this. I'm just going to put that in there for right now. And let's create a temporary variable called public float speed. And how's my broadcast volume right now? Okay, looks like it's good. So we're going to create a temporary variable. This is very similar to stuff we did last week to move the player around, but now we're going to make it move automatic, not based on player input. So new position equals transform dot position, and new position dot x equals transform plus equals speed times time dot delta time. As before, this is basically adjusting our x position based on the speed, and time dot delta time is used to make it so that it's based on the seconds rather than the frames. So as opposed to changing it based on speed every frame, it's based on speed every second. Once we do that, we actually set the original transform dot position, which is why I left it on here so I remember it. Hold on, there's something bouncing here, and I don't think they're talking to me. They weren't. Okay. So transform dot position equals new position. So this isn't going to do a whole lot except move the enemy off the screen, but we're going to give it a shot here and see how it works. So we have our enemy AI, and it says new position does not exist in the current context. And it's because I misspelled position. So position. There, that looks about right there. Save it again. So you'll get that sometimes if you misspell things. And I want to make more mistakes than less so that you can learn from them as well, but we'll see what happens. So now we just need to put this on an enemy, and I'm going to put it on our prefab, and that should make it so all the enemies change. So if we go in here, we should see our enemy AIS script near the bottom, and its speed is 0, which isn't going to do much, so I'm going to make it 1. And we're going to hit play and see what we get. Alright, we have enemies. They are moving to the right at about 1 unit per second. That's good. That's a good sign. So, from here, we want them to move to the right to about the edge of the screen and then start moving to the left. So, how can we do that? So, we're going to have, we're going to add a variable up here. It's going to be a private int direction. Probably should use an enum here, but I don't want to confuse people too much. This is just going to be a number. An int is an integer, which is a number, a whole number. And we're just going to have it be 0 for left and 1 for right. Actually, maybe it would be better to actually do... Yeah, we'll do 1 for right and -1 for left. I'll show you how that works. So the direction is going to we're just going to multiply it in, and we're going to default it to right. So equals 1. And we're going to multiply it into this equation now. Equals speed times time.delta time. We're going to add times direction. So this automatically will change the amount that it changes it by 1 or -1 once we put that logic in. And that'll make it so it's automatic. We don't have to do an if statement or any state information for this. So what we need here, though, is we need to actually change the direction when we reach some point. And that's the wrong button. Ignore that. So if new position, we're going to need world space to screen space of some kind. So we're probably going to have to use some Google here. But the basic theory is if transform.position.x is greater than some number. So I'm going to put a temporary variable in here so just so we can see how it works, and then we'll get more fancy and actually have it be based on where the screen edge is later. So not private, we'll make it public. So public float right edge and public float left edge. So is greater than right edge. Let me save it so I get autocomplete. We're going to set the direction to equal -1. And again, what this is doing is we're multiplying it in, so if it's -1, whatever our speed is will become negative and it'll start moving in the opposite direction. And if transform.position.x is less than left edge, we're going to make the direction 1 again. So let's give this a shot, and I'm just going to eyeball this real quick, but so our screen edge is probably going to be around 6, so I'm going to set that as our defaults first. So right edge is 6 and left edge is -6, and we'll see how this works. Oh, they crashed into each other and exploded. That's interesting. Must have done something seriously wrong. Let's just do one enemy to start with. I'm just going to disable these guys on the edges. So these two. I'm going to click this little tag, and that'll turn them off for right now, which allows us to bring them back in very easily once we get things working right. So here goes the enemy, and it's just jiggling. What's its position? It's just moving very little. So let's go back to our script and see what we're doing here. So, oh, that makes sense. So if it's bigger than the right edge, we're going to need to make this an else if. So what that means is if it's bigger than the right edge, it goes to the other direction, and this is probably not going to work, but maybe it will. Let's give that a shot. So let's play it again. Nope. All right. So, whoops. So here we go. If transform.position.x is greater than right edge, less than left edge. I did make left edge negative, right? Oh, it didn't actually save. That's probably the problem. 6, -6. That was probably because I was running it at the time that I changed it. Okay, there we go. That's looking more like we expected to work. I don't think we actually needed that else if. Okay, and it's bouncing, and in theory it'll bounce from the other side. Let's make it a little bit faster so that we don't have to wait as long. Oh. Huh. Oh, this is the prefab. Got it. Sorry. If you change stuff on the prefab, it doesn't propagate in real time. It only propagates at the time that the unit is instantiated. So we actually have to change it on this guy. There we go. So now we can tweak the speed. So let's make them move a little bit faster, but not too fast. Let's do 2.5. So we're going to go 2.5, and we're going to put that on our enemy. And we're going to see how this runs. Alright, cool. And if we turn on the other enemies, they're probably going to bump into each other and destroy each other on the right side of the screen. But we'll see how this actually works. So here we go, enemies, and they all crash into each other and die. Okay, so that works. Was expecting that to happen. For this case, let's make it so they don't collide with each other, and that way they'll just pass through. It won't be what we're gonna finally go with, but it'll work for right now. So we can change what objects collide with each other by using collision layers. So I'm going to put these guys on a layer. We're going to add a layer, and in the user layer 8 we're going to make it enemies. And this will make it so we can filter it out in the collision manager. So now we're going to actually put these in the enemies layer, and we're going to go into Edit, Project Settings, Physics. Now from here, this is a grid, and it's a little bit intimidating at first, but it's pretty simple how it actually works. Basically, this row collides with these rows. So default collides with itself, collides with transparency, collides with ignore ray cast, etc., etc. Same thing with here, transparent effects, although you have to also check on this column, and ignore ray cast, and water, and enemies. So enemies do not want to collide with enemies. So we just uncheck this. I'm gonna save the scene and save the project, and although that doesn't actually matter, that should just work. But when we hit play, hopefully these things will just pass through. There we go. We already fixed that problem real quick. And actually, that wouldn't be terrible if that's the way they always worked, although we can probably just kill them all in one shot if we... Oh, Oh, they collide with the explosion gibs. So I'm going to fix that too. So we're going to go into the gib, and we're going to create a new layer called gibs. And again, we're going to go into gib, set it to the gibs layer, and we're going to go to edit, project settings, physics, and we don't want gibs colliding with enemies. So now we won't have that problem of the explosions killing enemies, unless you want that behavior. I mean, nothing wrong with that, although it would make the game quite easy. So that seems to fix that problem. I still think I can catch two at the same time if I time it. Yeah, got them both. That's worth bonus points. At least when we do points, we're going to make that worth bonus points, maybe. I don't know. So we have them bouncing off the left and right. Although I kind of wanted to just automatically figure it out from the screen. So I'm going to Google a little stuff here and see if we can get the screen position based on their position, which is going to require a couple transforms. But hopefully we can figure this stuff out. So let's hit up Google and Unity screen width. So screen.width. So this is one thing that we're going to be using here. This gives the width of the screen window in pixels. So that's not 100% helpful for us because our units are not actually in pixels. So our units are in some other unit base. So most of our things are 1 unit, and there's only about 7 or 8 units wide on the screen. Well, no, sorry, double that because it's negative and positive. So, but we are going to be using this. So screen.width, I'm just going to go ahead and copy and paste this into our script just as reference. I sometimes just do this so that I remember things. Obviously, this is going to cause compile problems, but we're going to fix them up. And we need to get world space to screen space unity. So let's see, world to screen point. What does this do? This looks useful. Screen space is defined in pixels. That's what we want. Actually, we want the opposite. We want... No. Yeah, this will work. All right, so we're going to copy this over. Actually, I want the C# version. Where's the camera? Oh, yeah. We're going to have to... So this is actually based on camera. So I'll show you how to get that. I actually remember that one. So we're going to throw this in here as just something to look for. So we to get the camera, I think it's camera dot current dot world to screen point. So that's our function right there. So let's get rid of this. And we are going to check to see if... So what we're going to do here is we're going to paste this in here. And this thing takes a position. So we can just give it the position of an object, and we can get the X position from that. And that should be the actual position in screen space. Although we're getting, oh, that's because of this. So, and we're going to compare this to the screen width. So instead of comparing to right edge, we're going to compare it to screen.width. And this should work for the right-hand side. So I'm going to go ahead and save this and make sure it works at least on the right-hand side. Now they're going to go slightly off screen because this is based on the center of the object. So they should go halfway off and then come back. All right, that's pretty close. That's what we expected it to do. So on the other side, it's just going to do the normal thing here. So now we're going to fix it on the other side. So I open that up again. Let's ignore that. I'm used to actually running Unity and Mono on the same screen, and so I'm just not used to switching back and forth yet. So here we go. And Google didn't fail us this time. I'm very happy about that. So On the other one, we're going to be checking the same information. What this basically means, okay, so this is kind of a complex concept, but there's different, so the screen is pixels basically, and it starts from 0 on the left-hand side, and it goes to the screen width on the right-hand side, and the distance in the screen space is in pixels. And in world space, it's whatever your camera is currently pointed at. So if it's like zoomed in on something, it'll be a different ratio than if it's not. And so you need some way of converting it. And Unity has this function that's built in that allows you to do this conversion. It's a method of the camera class, and so you need a camera. Camera.current gives us whatever camera is currently enabled, and we only have one. But we could have a variable for the camera and use that, but this will just give us the one that we want. And world to screen point takes all of the effort out of actually making this conversion. You just give it a position, and it will give you where it is on the screen. And the .x gives us just the horizontal component, and we compare that to the width, and that's how it's going. That's how it knows to move back from the edge of the screen. And so the same thing down here. We can just use this for our left-hand side of the equation, and we're still going to look for less than, but we're going to compare it to 0 because the left-hand side of the screen is always 0. So this should put it on both sides. Oh, compiler errors. T camera does not exist. I had a typo. There we go. Else if T camera. Didn't copy paste right. And actually, we don't even really need an else if. Whatever. So this should give us. Okay, why are we getting a null reference expression here? Exception. Can't talk today. Why does it say that? That's cool. They got squished together because I changed the width. Camera.current.world to screen point transform.position.x. I don't know why we're getting a null reference exception, because it seems to be working. It even adjusts in real time. We're getting a lot of them. Is it spamming? It's totally spamming. Yeah, this collapse thing is a useful feature. If you get the same message over and over again and you have collapse on, it just shows you those messages. But it's useful to turn that off to find out if you're getting an exception like every frame, which it looks like we are. Why is this giving us that problem? And yet working very nicely. Well, I'm just not going to worry about it for right now, as it seems to be working. But if I figure it out, I'll have a little, I'll put some information somewhere about what the problem was. So we have them moving back and forth, and if we want to make it a little bit more like Space Invaders, we can have them move down as they go down. So we're going to go back to our enemy AI script. I'm mumbling a lot today. Sorry about this, folks. So what we want to do is, instead of just changing the direction, we're going to also make it move down a certain amount. So we don't really need right edge and left edge, although I'm going to make these into another variable called padding. So this will make it so we can make them move before they get to the edge of the screen, or after actually if we set it to negative. And we're just going to make it do screen width minus right edge padding and 0 plus left edge edge padding. And that'll allow us to move them in from the edges a little bit more. And we need a new public variable, public float, drop distance. This will be for them moving down. So we're going to change the direction, and then we're going to go ahead and do this kind of thing again. Just basically copy and paste that. And because we've already declared new position, we can just reference it here. And as a matter of fact, we can't actually redeclare it. So that's what that squiggly line was about. So same concept, except we're doing Y, and we're doing drop distance. Though we don't care about the direction. And we want to do minus equals because we want it to go down. And finally, we actually don't want time.delta time. This should execute, it'll execute more than one time, potentially. So we also need to make sure that we move the X position so that it doesn't execute this again. So new position dot X equals, going to be doing similar to this line here, although it's going to be camera dot current. Is there another camera? Main. Actually, maybe that'll work better. Main. Let's see if this gets rid of our other problem. Camera dot main dot screen to world point. There we go. Screen width, screen dot width, and so that'll put the position, and because we're using greater than that should work, and this should only execute once. Of course, you never know until you actually try this stuff. So let's do the other side too while we're feeling lucky. And this time it'll be 0. There may be a little fudge because of this conversion, so we might have to put a little fudge factors in here. Let's see what happens. So we have errors. Screen to world point. Oh, screen dot width. So it'll be, we don't care about the first point, so what does this actually return? A vector 2 or a vector 3? Camera.main.screen to world point. Returns a vector 3. Alright. So, wait. Whatever. Vector 3 position. Okay, so it takes a vector 3. That's what we were actually caring about. So, we need new vector 3. And we don't care about what, we care about X, so screen dot width. We don't care about Y, so we'll just put 0. We don't care about Z, we'll just put 0. And put another bracket, and it likes that now. So let's save this, and let's copy this over again. Wait, I didn't get everything there. And this time we want just 0. So this is probably looking more complex than it actually is, but basically we're checking to see if the object is, we're just making sure that the object is not past the screen boundaries, so that it's only executing these once, so that it doesn't just drop a whole bunch. So, and actually I'm going to make the drop distance equal 1.0 f by default, so I don't have to remember that in the other area. So let's hit play. Oh yeah. So this returns a vector, so we need a dot x here. And again here. Because we only want the x component. And let's give this a shot. Alright, we got rid of our null reference exceptions. It dropped, although went to the center. That's kind of cool. Obviously, I did the math wrong somewhere. It's doing something, though. It's close to what we want. I'm curious if they're going to... Yeah, they're probably going to collide with the player and not do a whole lot when they actually get down here. Let's watch it happen just for fun. Oh, yeah. They just blow up the moment you hit them. Yeah, we're the Uber player. Alright. So, what are we doing wrong? Screen.width. Screen to world point. And the X position is the problem. So, we're getting a 0 there somehow. Screen to world point. Why would screen to world point take a vector? Oh, because it's x and y. So let's find out what's happening here. A good way to do this is to use debug.log. Debug.log. So debug.log, and we're going to just log exactly this line here and see what we get. And what this will do is it will show us what that's returning in here. And I'm assuming it's just going to say 0 because of how it's behaving, but we'll see. Yep, 0. That's what it's saying. And here's the collapse thing in a good case. So it shows that every time that it happens, it shows up. But if it's the same message, it collapses them, although it didn't collapse all the way. Don't know quite why. So, yeah. Let's see. Screen to world point. Let's just try this just for fun, even though I don't think that's going to do anything. Oh yeah, I think I remember having this problem once on one of my projects. I think it had something to do with you had to give it a forward vector for some reason, like the Z mattered. So I'm going to do that and see if that changes anything. Let's see what we get this time. Well, better. That's not... Oh, I see. Okay, we're going to have it... So it's relative to the camera. And these things are at 0, right? So we may have to figure out how far these things are from the camera. I'm just going to hard code it this time. Though we could probably... Yeah, we can make that not hard coded. Let's hard code it first, make sure that it fixes the problem, and then we can make it fancier after that. So we're going to make this 10, so that means 10 in front of the camera. And we're going to see where this gives us. Yeah, there we go. That was the problem. So what this takes, and actually, let me just pull up the Unity docs. Camera, screen to world point. So transforms screen space. So okay, so this one uses the near clip plane. I'm not sure if that would work for us. World units from the camera. There we go. Z position is world units from the camera. So you need to have that for it to line up properly, because otherwise, if you had an object that was very close to the screen, obviously, like if you zoom in on this and pan, how do we pan? That's not pan. One of these buttons has got to pan. Okay, whatever. But anyway, as objects get closer and farther away, like if you get close, you can see, like this one object is like just a little bit off to the left of the middle of the screen, but if you were very close to it, it's nearly off the edge of the screen. So that's why the Z position mattered. So what we can do is actually have it be based on how far away the camera is from the object's position, and based on the Z. And that should fix the problem in a way that if we adjusted things later, it'll still work. So let's try that. I like things to work in the general case because it's really frustrating when you change, like you want to reorganize your game and you start moving objects in Unity and moving things around so that they are different and exactly the way you want them. And then after you're done with that, you realize that you've got all these hard-coded values that required the objects to be in exactly the position they were in. So we want to get the difference between where this object is based on the Z and the camera position. So we're going to create a new variable here, float camera object difference, Z difference. Let's be really specific about what this does. And that we can actually just assign it on this line. So it'll equal our camera dot main dot position, no, transform dot position dot Z, and we want it to be the difference. So we want this to be 10, so we're negative 10, so it'll be the position of our objects at transform dot position dot Z minus camera dot main dot transform dot position dot Z. And we're going to use this variable here and here and here and here. So if we run this now, it should work exactly the same as it did before. Well, oh, we need to redeclare this. And I'm going to go ahead and get rid of our debug log messages as we figured out the problem. How are we doing on time? I don't even know. There's not enough room on my screen to show the time, so maybe it'll show up in the other app. And it does. Alright. We're still doing good. Alright. So we're going to play again. And these things should behave as they did before, which they do. That's good. Now let's give a test. Let's take the player, and let's say we wanted the play space to be smaller and even more cramped than it already is. So we're going to move it in like 5. And see if these guys still go to the edge of the screen. Okay, and it's working. So now it's working in the general case, and we can feel good that we solved that problem and that we can tweak the camera around and it'll still work. As a matter of fact, it'll probably even work in some weird case. So let's rotate the camera a little bit around the y-axis. Let's do like this and see if this works. This is kind of a crazy example. So they're going to go way, way out into infinity, and then, oh, didn't quite work in that case. Well, I wasn't trying to get that one to work. So yeah, not sure if. Oh yeah, that's because we're just using the Z component. We're going to have to be more math fancy than that. So at least we can move the camera and zoom the camera, and it'll still work. So -10, like we were before, and there we go. So we have enemies moving. We don't have them colliding with each other. We, what else did I say I wanted to do at the beginning of the show? So, how about we make it so that the enemies can kill the player as opposed to the opposite? Like, we'll have the enemy kamikaze into it, so it'll still blow up, but the player will blow up as well. So, what do we have? We have Gibbon Collide. So, we could just throw this on the player. And if we have an enemy go very quickly into us, we just speed it up. Whee! And bam! Alright, no player. Excellent. And we could have him explode like the enemies, but we'll just have him disappear for right now. Again, how you could change that is our Gibbon Collide has an array of objects, and you can just drag objects in, and that'll make the those objects instantiate when you die, and it'll apply an explosion force on them. Which on our enemies, we've got just a whole bunch of the same object, and then an explosion force and a spawn radius, and that's how those things explode like they do. Again, you can check our previous episodes to see what we did, and in this case, it's a continuation, so I apologize if you don't have the old project in front of you, but you can always get it. It's available online. Information's on the right. So, here we are. 8:42, got a little bit over 15 minutes to work on this. So, let's add scoring. Actually, no, that's what I was going to say. We were going to have the enemies spawn themselves so that we don't have to manually place a whole bunch of enemies. So let's make a new object. Actually, this create menu, for whatever reason, does not have an empty game object in it. You'd think that that would be in there, but it's actually instead in assets, no, game object create empty. So this just gives us a object that only has a transform. That's all it has. And that's the minimum number of things that an object can have. So we're just going to put it at 0, 0, 0, even though its position we're not going to care about. And we're going to call this the enemy manager. And we're going to have this thing spawn enemies. So we're going to create a new C# script called spawn. Let's do spawn objects. We'll make it generic named so that we can reuse it later, because this would work for spawning anything. It doesn't have to spawn an enemy. So we open this up and monodevelop resets. Oh, there we go. Back to normal. Alright, so spawn objects. Another fresh script to work with. So on this one, we're only going to need start because it only has to spawn these things once. So I'm just going to get rid of the update right now. And what we're going to do is we need some variables. So let's do public float dot spawn width, public float spawn height, let's do area to be more specific, and then public float, actually int number of enemies X and public int number of enemies Y. So the theory is I'm going to make this so we give it a spawn area width, a spawn area height, and it will, and actually I said that the position is not going to matter. We're going to make it matter. We're going to make it so the spawner is the center of where the enemies are going to spawn, and it will spawn in a width and height around that center with a number of enemies horizontally of number of enemies X and a number of enemies vertically this Y. And I want to do this mostly because I want to show you a cool little thing you can do to visualize them in the editor as well. So we're going to start by making it just work. So, oh yeah, and of course we need a object type. So public game object, and that won't work because that's a keyword. Game object spawn object. And we're going to go into the start here, and we're going to do a couple for loops. So for I equals, int I equals 0, I is less than number of enemies X, that's correct, and I plus plus. So what this is going to do is it's going to cycle from 0 to however many enemies we have on the X coordinate. And we're going to do a nested one that's the same thing, int j. We just need a different variable. J is next to I in the alphabet. I is less than number of... stupid autocomplete failing. Number of enemies Y, J plus plus. So, oh, don't need a semicolon there, that'll get us into some trouble. So, we're going to spawn, let's see, spawn area width. How are we going to do this? Math is hard for everyone. So, let's just start typing stuff until it comes to us. So we're going to want to instantiate a spawn object, and it's going to be, we're going to call it spawn position. We haven't made this variable yet, and that's why it's saying no matches and scaring me. And we're just going to use the orientation of our transform. So transform.rotation. Now we need a spawn position, so we're going to do a vector 3 spawn position, and we're going to just set it to our transform.position right now to start with. And then what we're gonna do is actually let's make it not spawn from the center. Let's make it spawn from it'll be the upper left point, and that way we don't have to do as fancy on the math. It doesn't really matter. We're gonna make it so that it's pretty obvious where they're gonna spawn in a later step. So the first position is going to be just the transform dot position. So we're going to be adding to the X and the Y based on the spawn area width, spawn area height, and the number of enemies. So spawn position, let's work with the X, dot X equals, a lot of this you could probably do in a single line, but I like to break it up just so that we can visualize it, and we can always make it to a single line later. And also, there's some people that say that you shouldn't have lines that are too long anyway, just for readability's sake. So spawn position.x plus equals something to do with I, so, and a number of enemies. So it'll be I times So I times the spawn area width divided by number of enemies, maybe? Let's see, that would give us a percentage. Okay, so that would give us the amount of units per enemy. And I, that's perfect, that should work. And we're going to do the same thing with spawn position.y, except for we're going to do spawn area height and number of enemies y and the spawn position y. And we're going to give this a save, and we're going to attach it to our enemy manager, and we're going to set the variables in this to, let's make the width 5, the height 5, and the number of enemies 5 and 5. So this should give us an array of a whole bunch of enemies. We hit play, and we didn't assign the variable. So we need to go back into our enemy manager. We need an object here to spawn, so we're going to put our enemy here. Hit play. And oh shit. Obviously I had a problem, and that's a little unfortunate because I didn't save at any time. So this is a lesson to everyone here. Be sure to save as you go along. I'm going to force quit this real quick, and we're going to reopen Unity. I'm going to very quickly make sure that we get back to where we were at. I don't think we did many changes to what was actually going on in here. I had the wrong project open, didn't I? Oh well, doesn't matter. So let's see if this does what we expect it to. It's not going to because the scripts aren't on them. Oh, wait, no, the scripts are on them. Oh, we did save at some point. Thank you. So that's good. And the enemies don't seem to be colliding. That's good. So we're going to go back. It looks like all we lost was our enemy manager. And we're going to throw spawn objects on it. And we're going to, let's do 1, 1, 5, 5, and enemy. And let's look at our script to see what we screwed up. Actually, I'm going to save this real quick. So, J. So, this one. Are we doing too much here? Let's see. For I equals 0, so it spawns. Oh. Maybe we're doing something wrong here. We're probably creating more objects than we want to be. Let's see what it does with 1 and 1 here. And yeah, we're screwing something up. Or I'm screwing something up. You guys are doing just fine. This stuff happens. This is how we do it, one step at a time. And that's the reason I saved before running it again. So go back into our level, enemy manager. What are we doing that is making it so unhappy? I is less than number of enemies X. I is less than J is next. Oh, I and I. That was it. This is gonna do it. I have a good feeling about this. Alright, it worked. Although it's using the wrong transform and it didn't look like they were very wide. And it only made 1. Oh, that makes sense because we only told it to make 1. So let's... What is the enemy default? Does it have the rotation in it? Okay, it does. So we actually don't want to use the transform.rotation. Is there a way to get... Let's see if we do spawn object dot transform dot rotation. Let's see what that does. See if that fixes the rotation problem. It does. All right. And looks a little different. I think that's just because of my wide angle on this stuff. So enemy manager. Now we're going to try 5 and 5, and we'll see what that does. Oh, and they all collided really badly. I swear that. Oh, they're enemies. That's fine. They're default. We didn't actually change the prefab, so gonna save it. Save project. Save early and often. Something I haven't been doing on the show. Okay, that's actually looking about right. Like, we have them too cramped, but if we uncramp them by changing the spawn area width to like 10, the height seemed okay. Yeah. So this is actually working to spawn our enemies in initially, and now we don't have to like do as much work. Why are these guys going faster? I guess they have a different speed than the prefab. 2.5. The prefab is 2.5. Huh. They seem faster. They seem considerably faster. Are these things... What are these? We can look at them while they're running. 2.5. Are they the same scale as our enemies? Oh, they're in a different position. They have a Z position. Probably because we have a Z position on our enemy manager. Here we go. So, if we do 0 here, and go. Alright, so we have a whole bunch of enemies, and we can just plow through them because we don't destroy our... Oh! Huh. Did we not save the gib? Yeah, gib needs to be into... Oh, we don't even have that layer anymore. Alright. Gibs. We lost... This is stuff that we lost because of not saving. So remember, save. Save a lot. Save all the time. And we actually need to change the physics stuff again. So, gibs don't collide with enemies. So, let's see if that fixed our problem. There we go. That's how I expected it to go, where you just murder a whole bunch of enemies on a line, and they seem to be moving the right speed. And we don't even need these enemies that are built in anymore. I'm just going to get rid of them for right now. So, now I said that there was something cool I could do to visualize this, and this is going to be the last thing we're going to do this episode, and if I go a little bit over time, I do. But I need to look at some documentation here. So, editor, let's see, Unity editor, what are we going for? Draw stuff in Unity editor. Let's see what that gives us. Editor GUI, drawing lines in the editor. Let's see what this says. Huh. Okay. Unity draw in editor. Gizmos. So on draw gizmos. There we go. So we're going to do on draw gizmos. And this is a cool little function. So void on draw gizmos. What this is a function that is called by the editor when you're in edit mode, and it draws, and it actually can be called by the game camera too, and it draws stuff in it. So we have lines, spheres, arrays. We're going to be using lines. I like doing this for some reason, so I'm just going to put that here for right now. And so we're going to get a whole bunch of errors, and we're going to replicate this structure here. Just copy and paste it as is. And what we're going to do is, instead of instantiating, we're going to draw a couple lines. So it's called draw line. Draw line. Oh wait, gizmos. Gizmos dot draw line. And this takes a from and a to. So we're going to take it from spawn position and we want this to, we're going to make a little cross basically with these lines. So we're going to do 3 of them. So it looks like a little 3-dimensional cross. So spawn position minus vector 3 dot left and spawn position plus vector 3 dot right. And then we're going to copy this, and we're going to do 2 more of these. We're going to do, actually I should have just copied here so that, because it automatically puts the thing in there. And we need a G. Alright, so we're going to do up and down and forward and, is it back? It's probably back. Back. Yeah, alright. So what this is going to do, hopefully, is give us a little visualization in here. So I'm going to hit play, and I'm going to, so it played, and now we have it compiled. So our enemy manager, it's not actually doing what I want it to. It should be drawing things. On draw gizmos. Let's see. On draw gizmos. So that should be what we want. On draw gizmos. I'm going to just copy and paste it because I have a propensity for misspelling things. So gizmos. Is it not drawing my gizmos? What happens if I hit gizmos? No, it's totally not doing it. So let's see. I equals 0. What's the number of enemies? Draw a line. Oh, I'm not actually getting the, well, transformed opposition. This ought to work. Do I have to do anything else? Unity engine. No, doesn't look like I need to do anything fancy. Let's look at draw line. Gizmos dot draw line. Waiting for Unity 3D. While we're waiting, I'm just going to look at this again, see if anything pops at me. Huh, that should totally work. Alright, so I really want this to work, so I'm going to just go to my personal collection of scripts real quick. I'm going to probably have these publicly available at some point, but I'm just still cleaning them up. So, spawn grid, this was my script that was designed for this. So on draw gizmos. Maybe the lines are too long. I mean, the only difference here I can see is I'm putting a scalar in here. And this is a three-dimensional spawner. Alright, well, I've run over time, and it's not working. What should have happened is we should see in here on the enemy manager a nice little grid of where it's going to spawn things. But I don't see it. And I don't quite know why. So I guess we're going to call it a day there. Let's just position these things so that they seem like they're in a good position to start. That's pretty close. Let's move it up a little bit. So they're close to the top of the screen. Move it up a little bit more. Probably too far. Yeah, too far. Go down here. And let's change our spacing just a little bit. Let's actually just make the number of enemies Y a little bit less, and that will naturally give them space. And let's make the number of enemies X higher for fun, and the spawn width to be much higher, like 20. Let's see how that looks. And let's move it over to the left. And let's call that a day. So, anyway, thanks for tuning in. And I'll have this project file up for people to look at shortly, and have the link in the description of the video. Thanks for tuning in. This is Max Moreau. If you want to email me, my email is pushypixels@pushypixels.com, and give me feedback. Thanks.